Dear students, today class is complex number theory bits. Until previous class we have discussed the concept, theory, proofs and everything, whatever the formula is necessary for the complex number topic level 3. Now let us going to discuss about the theory bits. Theory bits. First one, I power n plus 1 plus I power n plus 2 plus I power n plus 3 when n belongs to capital N. So put n is equal to 1, it becomes I plus I square, I plus I square plus I cube plus I power 4. I plus the I square value is minus 1, I cube meaning I square into I, so minus 1 into I minus I power 4 is 1. 1 minus 1 get cancel, I minus I get cancel, answer is 0. Second one, Z1 is equal to A plus IB, comma Z2 is equal to C plus ID. It is meaningful R2 complex number such that Z1 greater than Z2 is meaningful. Z1 greater than Z2. In the real numbers 2i, 3i, 4i like that, we cannot decide that which is great in imaginary parts, not in real numbers. In complex number concept, example 2 plus 3i, 3 plus 2i, we cannot say whether 1i is great or 2i is great. There is no question of great or less or anything in the imaginary numbers. So it should be real number. Whenever it is meaningful, it should be real number. There is no question of imaginary part. So imaginary part should be equal to 0. That implies A, of course, Z1 greater than Z2 becomes whenever it is greater than this, so A greater than C, and B is equal to 0, comma D is equal to 0. Imaginary part should not be. Third one, the smallest positive integer n such that for which 1 plus I whole power 2n is equal to 1 minus I whole power 2n. 1 plus I whole power 2n is equal to 1 minus I whole power 2n. I think we have done this one in IP. 1 plus I by 1 minus I whole power 2n is equal to 1. We have substituted n is equal to 2. So n we have done n equal to 4. We have substituted there. So verifying if n is equal to 2, put n is equal to 2. So it becomes 1 plus I whole power 4. 1 plus I whole power 4 is equal to 1 minus I whole power 4. Let us verify here as 1 plus I whole square is equal to 1 minus I whole square. 1 plus I whole square becomes 1 plus I square plus 2i. So 2i whole square is equal to here minus 2i whole square. Of course it is 4 equal to the templates, 4 equal to 4. So n is equal to 2, option 3 is verified. Now the multiplicative inverse of z is, of course it is direct formula z bar by modulus of z square. If multiplicative or inverse of z bar, it is z by modulus of z square. Fifth question, z plus z bar is equal to 0. Z plus z bar. Z plus z bar is equal to 0. Then what? What is meaning of z? It is x plus I y. meaning of z bar x minus I by get cancelled 2x. So 2 into real z, that's all. It is z plus z bar equal to 0. So 2x equal to 0. So 2 into real z equal to 0. Of course, real z equal to 0, second option. Sixth question, z bar equal to 0. You can understand z bar meaning x square plus y square is equal to 0. Z is equal to x plus I by z bar is equal to x minus I by. If you multiply x plus I by into x minus I by, you will get x square plus y square is equal to 0. We know that every square greater than or equal to 0. Here there is no question of greater than 0. Absolutely he given greater than is equal to 0. That is why you can understand that x equal to 0 and y equal to 0. There is no other alternate. This is complex 0 complex. Oh, simply z is equal to 0. Whenever x is equal to 0, z is y equal to 0, you can write z is equal to 0. Next, sixth question. Z bar is equal. Yeah, this is sixth one. Seventh one, conjugate of z plus 2z bar. Conjugate of z plus 2z bar. Conjugate meaning whole bar. You can write this one as z bar plus 2z. Simply z bar plus 2z. Second option. Next, let us discuss eighth question. The complex number z is equal to 1 plus a represented by the point in the arched plane. In the arched plane, and OP is rotated an angle pi by 2 in the counterclockwise direction. They are the resulting complex number. Right here, this is O, this is Z2. Counterclockwise direction, this is theta is equal to pi by 2. You can write by Coni's theorem. Modulus of general Z2 by Z1 is equal to modulus of full modulus Z2 by Z1 into e power I theta. So here Z2 is new. The complex number Z is equal to 1 plus a represented in the point in the plane OP rotated with an angle. We can understand here Z1 is equal to 1 plus I. If we are rotating, put here this is Z2, this is Z1. We are rotating the value, rotating a complex number to pi by 2. There is no change in the distance from origin to this position and this position. Position may change, but distance will not change. So Z2 by Z1 is equal to simply it is 1 because there is no change in the magnitude. So e power I pi by 2. E power I pi by 2. So Z2 is equal to 1 plus I into Z1 meaning 1 plus I. E power I pi by 2 meaning cos theta plus I sin theta, cos pi by 2 plus I sin pi by 2. So 1 plus I into 0 plus I. So I minus 1 you can write otherwise minus 1 plus I. Option according to option given as third option. Let us verify third option minus Z bar. So what is Z bar? Here Z bar. Z bar meaning 1 plus I. So minus of 1 plus I whole bar. That is equal to minus of 1 minus I. Multiplied becomes minus 1 plus I. Correct. Third option verified. Ninth question we have done already in the conceptual. 10th one. Imaginary of Z bar. Of course Z bar meaning x square plus y square. There is no imaginary. So it is simply 0. 11th one. We have completed while going to discussing the concept. 12th one also completed. Let us going to discuss now 13th question. Minus root 3 into minus root 75. This is an MCQ easy bit. Everyone used to understand as root A into root B value as root AB. So 3 into 75 minus into minus plus 3 into 75 root is 50, but it is wrong here because root a into root b is equal to root ab in the concept of real numbers, but here root, this is not root a, root of a square. This is not root b, root of b I square. So in that manner you can understand this is imaginary concept. Root of 3 square into 75 square. Now you can write 3 into 25. 3 into 75 is 225 to I square into I square. I power 4. I power 4 will separate I square. Now this is 15 into I square. So 15 into minus 1. Minus 15 is correct answer. Yeah. Next one, square root of 8 minus 6i. Let us remember the formula. Root of a minus ib is equal to plus or minus into root of here square root of a square plus b square plus a here over root by 2 minus I into root of a square plus b square. Square root of a square plus b square minus a whole by 2. Apply here the a meaning 8 b meaning 6, 8 square plus 6 square 64 plus 36 100 100 10 plus 8 10 plus 8 18 18 by 2 9 9 3 minus I into 100 minus 8 100 meaning here 10 minus 8 means 2 by 2 1, so this is 3 minus I. Root of 8 minus 6 equal to 3 minus I. 15th question, modulus if z1 comma z2 are two complex numbers. If z1 comma z2 are two complex numbers such that modulus of z1 is equal to modulus of z2. Modulus of z1 is equal to modulus of z2 and argument z1 plus argument z2 is equal to 0. So let us going to discuss. Take an example. Let z1 is equal to 1 plus I and z2 is equal to 1 minus I. 1 plus I modulus is root 2 and 1 minus I modulus is also root 2. If you multiply with 2, it becomes, if not 2, with the root 2 it becomes root 2 into 1 by root 2 plus I by root 2. So root 2 cos pi by 4 and this is root 2 sin root 2 cis pi by 4 and root 2 cis of minus pi by 4. So pi by 4 is argument here theta 1 equal to pi by 4 and theta 2 is equal to pi by 4. So argument of z1 equal to pi by 4. Argument of z1 equal to pi by 4 and argument of z2 is equal to minus pi by 4. So argument z1 plus argument z2 is equal to 0. It's okay. Depends upon the concept we have. Simply I am thinking this is a shortcut 1 plus and 1 minus I. Each any number you can take. Otherwise you can do x1 plus I by 1 x2 minus I by 2 like that. The whole process you should do. According to this concept you can say the third option verified conjugate to each other. Next one. 16th one. Z1, Z2, Z3, Z4 are two pairs of conjugate complex numbers. Argument of Z1 by Z4. Two pairs of conjugate complex numbers. Argument of Z1 by Z4 plus argument of Z2 by Z3 is equal to dash. Z1 and Z2 and Z3 are conjugate complex. Let us calculate Z1 is equal to I and Z2 is equal to minus I. Same values I am taking as a previous sum. Z3 is equal to 1 plus I and Z4 is equal to 1 minus I. Conjugate complex numbers have taken. Now argument of Z1. Here argument of Z1 is equal to pi by 2 because cos pi by 2 plus I sin pi by 2 model. Next argument of Z2 is equal to minus pi by 2. In the similar way argument of Z3 is equal to pi by 4. Argument of Z4 is equal to minus pi by 4. That implies argument of Z here I am writing argument of Z1 by Z4 meaning is argument of Z1 minus argument of Z4. What is argument of Z1 here? 5 by 2 minus 5 by 2 plus argument of Z2 meaning minus 5 by 2 minus 5 by 2 plus 5 by 4 because minus of that is 0. Total answer is 0. Now 17th question. Modulus of Z is equal to 2. Modulus of Z is equal to 2. Argument of Z is equal to pi by 6. Modulus of Z is equal to 2 and argument of Z is equal to pi by 6. Then what is the value of Z? Of course, pi by 6 root 3 plus only simply directly third option. Directly third option we given as root 3 plus I. If you multiply and divide with 2, this is root 3 plus I root of 3 square, root of root 3 whole square plus 1 square becomes 2 and this is 2 into cos pi by 6 plus I sin pi by 6. It is enough. Next 18th question. A less than 0 given. So A you should calculate negative value. Argument of IA. Argument of IA becomes argument of I plus argument of A. Argument of I meaning pi by 2 minus A. So of course it is argument of IA. A less than should. You should not consider like this. A you did not give any number. Simply A less than. So argument into take any number minus 1 like this. Of course minus 2 minus 3 anything. Simply I am taking A less than 0. A is equal to minus 1. So argument of minus I becomes minus 5. Ninth one concept completed, 20 completed, 21 completed, now 22, not 19, 20, 21, 22 now I am discussing. If A, B, C are real numbers, A plus B plus C equal to 0, AZ1 plus BZ2 plus CZ3 is equal to 0. I think already we have completed this sum IPE in the concept of PZ1 plus QZ2 plus RZ3, where B plus Q plus R is equal to 0. Proof I said IP sum. IP sum exercise 1D Roman number 2 fourth question. So it is concept is collinear. Depends upon Roman number 2 first question is also we have discussed the first and fourth are similar way. Answer is collinear points. Now 23rd. Third question. Let Z1, Z2 be two complex numbers such that Z1 by Z2 with Z2 by Z1 is equal to 1. Then origin and points are represented by Z1 by Z2. Z1 by Z2 plus Z2 by Z1 is equal to 1. That implies you can understand this one as Z1 square plus Z2 square is equal to 2Z1 Z2. No, not 2Z1. Simply Z1 Z2. Whenever the formula we have discussed Z1 square plus Z2 square plus Z3 square is equal to Z1 Z2 plus Z2 Z3 plus Z3 Z1. Then Z1 Z2 Z3 represents an equilateral triangle. If Z1 square plus Z2 square, if among them Z3 is equal to 0, so they represents an equilateral triangle. Of course, we given as origin. With origin, the triangle becomes equilateral triangle. Triangle is an equilateral triangle according to concept. Note number 8 is there in our material, page number 8. Equilateral triangle. 24th question. The necessary and sufficient condition for the points Z1, Z2 represents by PQ and OP perpendicular to OQ. I think this is the IBA question, Roman number 2. Fifth question is there. IBA question, exercise 1D, Roman number 2, fifth question. You see the question. There the question given as like this: Z1 Z2 bar, Z1 Z2 bar plus Z2 Z1 bar is equal to 0. Then we have proved here this is O, this is P, this is Q, OP perpendicular to OQ. Angle BOQ is equal to 90 degrees, like the question given as like this in IPE. Angle BOQ is equal to 90 degrees. Now 25th question, the region. We know that the locus concept PA plus PB is equal to K represents an ellipse. Modulus of PA plus PB less than K represents an interior part of ellipse. Whenever PA plus PB is equal to K, it represents an ellipse. This is interior part because it is PA plus PB less than K. Interior of ellipse. Now 26th one. 26th question. The equation modulus of Z plus I minus modulus of Z minus I is equal to K. Modulus of Z plus I minus modulus of Z minus I is equal to K. Represents hyperbola. Yeah, of course, hyperbola. Where the condition is there, I think K less than Z1 minus Z2. Hyperbola, yeah, K less than modulus of Z1 minus Z2. K less than modulus of Z1 minus Z2. Z1 meaning here minus 1 because you can understand as x plus I by y plus 1. X plus I into y plus 1. X minus 0 plus y minus half minus 1, you can understand. Like this. So A is equal to, here you can write Z1 is equal to minus 1 and Z2 is equal to 1. So modulus of Z1 minus Z2 becomes minus 1 over modulus, so it is K less than 2. K square is asking. So K square, so K only, yeah. That implies option 3, 0 less than K less than 2. Negative should not be. 0 less than K less than 2. According to modulus values of the complex number, you should not write negative values. So 0 less than K less than 2. Next one, the equation can represent ellipse. For ellipse, this is for hyperbola. The concept is here hyperbola. Here for ellipse. For ellipse, the condition is reverse here. So K greater than modulus of Z1 minus Z2. So what is K here? Here A is equal to 1 and B is equal to minus 1. Of course, A plus B. Here A minus B, 1 minus of minus 1 becomes 2. So by squaring both sides, K square greater than 4. That's all. 4, third option. Now Z is equal to 28th question. Z is equal to x plus I by modulus of Z minus AI. Modulus of Z minus AI is equal to modulus of Z plus AI. You can write here what is meant by Z, x plus I by. So x plus I into y minus A over modulus is equal to x plus I into y plus A over modulus. Modulus meaning root of component square plus component square. So squaring both sides, you can understand here x plus y minus A whole square is equal to x square. X square plus y plus A whole square. I think this is the exercise 1C Roman number 2, 4th bit. IBA question. X square get cancelled, y minus A whole square. This is y plus A minus whole square minus y minus A whole square becomes 4AB concept, 4y equal to 0. This is y is equal to 0, that is x axis. So answer is here x axis or y is equal to 0. Yeah. Next 29th question. Image square. Image square means imaginary part of Z square. So imaginary part of Z square. This is also IP question. X plus I whole square we can write. Im of Z square. So x plus I whole square formula x square minus y square plus with iy. So imaginary part 2y mz square is equal to 0. No, it is c mz square 2y into x, not 0. 2ixy. So I don't write I. 2yx equal to c. So xy is equal to c. xy is equal to c square or k square represents a rectangular hyperbola. Rectangular hyperbola. Argument of argument z minus 1 by z plus 1 is equal to pi by 2. Then what is the argument z minus 1 by z plus 1 is equal to pi by 2. Z is equal to x plus iy, and substitute the value x plus iy minus 1 by, so we can write here by taking common x minus 1 plus I, argument of x minus 1 plus I by whole by x plus 1 plus I by, taking rationalization x plus 1 minus I by whole by x plus 1 minus I by. Multiply here, it becomes x minus 1 and x minus 1. This is x square minus 1. And in real part iy into minus iy becomes minus I square, so it is simply plus y square. Plus I into x plus 1 into y, x plus 1 into y minus y into x minus 1 whole by x plus 1 whole square plus y square. So here argument of this one. Argument of a complex number is a tan inverse of imaginary part by real part. So argument of z is equal to theta is equal to tan inverse imaginary part by real part. So it is given as pi by 2. So you can understand pi by x is equal to tan 90 value infinity can be understood 1 by 0. So x is equal to 0. Its meaning is always real part equal to 0. So real part here, real part is equal to x square plus y square equal to 1. So it is a circle with radius 1, unit circle. The locus is circle with radius 1. The area of the quadrilateral formed by the points z bar. 31 question. The area of quadrilateral formed by points z comma, z bar comma, minus z comma, z comma, z bar comma, minus z comma, minus z bar. This same question we have done as a worked example 13, page number 8. There some mistake is there in our material. That mistake I said that ABCD is not a square, ABCD is a rectangle. So what is the area of rectangle? Length into breadth. There we got the area is equal to length we got 2x and breadth we got 2y. See worked example 13, page number 8. See worked example 13, page number 8. So 2x into 2y, so area is equal to 4xy. Now verifying the option. 31st question. Verify option. Mod in fourth option, mod z square minus. Fourth option, mod z square minus z bar. Mod z square minus z bar square. What is z square? This is x plus iy whole square minus of z bar square meaning x minus iy whole square over modulus. A plus b whole square minus a minus b whole square formula 4ab. So 4 into modulus of x iy. Of course, for iy you can understand modulus is we understand as 0 plus I into 4xy. Root of component square plus component square gives simply 4x. So this is the option. Verification. Verified fourth option. 32 and 33 we have discussed in concept. So now 34. If n is an integer, 1 plus I root 3. 1 plus I root 3. Whole power n. 1 plus I root 3 whole power n plus 1 minus I root 3 whole power n is equal to 2 power n plus 1 into cos n theta. No. Cos theta. Then what is the value of theta? Of course, you can understand this one as 1 by 2 into multiply with 2. So according to that is equal to x plus I by is a complex number. Its modulus amplitude form is r into cos theta plus I sin theta, where r is equal to root of x plus y square, theta is equal to tan plus y by x. In the similar way, you can understand this one as again multiply with 2. 2 into 1 by 2 minus I root 3 by 2 whole power n. 1 by 2 becomes cos 60 plus I sin 60 whole power n. 2 power n. 2 power n taken common. Here always whenever plus is there, you will get only real number, that is nothing but cos theta. Of course, it is cos 60. So you can write directly this one 2 power n plus 1 into cos n by 3. So theta is asking that theta is equal to n by 3. Theta is equal to n by 3. It is first option. Let n be a positive integer. 35 question. A plus ib into a minus ib. I think this is ib sum 35 question. IP de Moivre theorem is there. IP sum directly I am writing there. In example, he given to us that p plus iq whole power 1 by n plus p minus iq whole power 1 by n is equal to 2 into p square plus q square whole power 1 by 2 n cos 1 by n arc tan q by p. I said the question. So you can understand 2 into a square plus p square whole power 1 by 2 n into cos 1 by n tan plus p by a. First option. If you are having any doubt, write as a is equal to r cos theta and b is equal to r sin theta and then proceed. Now, in concept we have discussed the 36 question, 37, 38, 39 also completed. Now let us going to discuss from the 40th question. Question number 40. If alpha beta are the complex cube roots of unity, then find alpha power 100 plus beta power 100 plus 1 by alpha power 100 into beta power 100. So alpha is equal to write as omega and beta is equal to omega, because he said that alpha and beta are the complex cube roots of unity. For unity meaning 1 for 1, cube roots are 1 comma omega square. So alpha is equal to, of course, 1 need to write. Alpha is equal to omega, beta is equal to omega square. Write here omega power 100 plus omega power 200. Omega power 100 plus omega power 200 by omega power 100 into omega power 200. One concept we have discussed that sum of the roots of the unity is 0 whenever it is not multiplied of p. So whenever p is equal to kn, Simply we have discussed that it is not multiple of k. If it p not equal to kn, we can write p not equal to kn, we can write that 1 plus 1 plus 1 plus so on n. If p is equal to kn, we can write this 1 plus omega square concept, it is nothing but 0. So omega power 100 and plus omega power 200 becomes minus 1. Plus this is 1 by omega power 300, you can understand as omega power 100 whole power 3. So it is 1. So minus 1 plus 1 becomes 0. Now 41st question. 41st question. A plus b whole square. A plus b whole square. A plus b whole square plus a omega plus b omega square whole square. A omega plus b omega square whole square plus a omega square plus b omega whole square. A omega square plus b omega whole square. So here better to take here students put a is equal to 1 comma b is equal to 1 without taking 1. In IP we have done that some x plus y whole square plus x omega plus y omega square whole square plus x omega square plus y omega total whole square. I think I given the work to you. Now simply you can put the shortcut by a is equal to 1 and b is equal to 1. Substitute here 1 plus 1 becomes 2 square means 4. Of course this is omega plus omega square becomes minus 1 whole square. Of course this omega square plus omega it is minus 1 whole square. Answer is 6. Whenever we thought a is equal to 1 and b is equal to 1, you can understand here this is 6ab. Now 42nd question. 42nd question. If omega is a cube root of unity and n is a positive integer such that 1 plus satisfying 1 plus omega power n plus omega power 2n equal to 0. That all I am discussing students. Whenever it is not equal to 0, that is it is n, you can say that it is multiple of kn. That meaning it is multiple of 3 or 6 or 9 or 12 or like that anything. If it is not multiple of 3, always its value is 0. Not multiple of 3 options are, first option 3m is there, so multiple of 3. It is not correct because here given as 0. 3m plus 1, whenever it is 3m plus 1, it is not at all multiple of 3. It is correct answer. 3m plus 3, of course it is multiple of 3. 2m plus 3, it is not at all multiple of 3. This is unrelated answer. So option 2 is the correct answer. Directly you can write. Next 43rd question. A is equal to cos 4 pi by 3 plus I sin 4 pi by 3. A is equal to cos 4 pi by 3 plus I sin 4 pi by 3. The value of 1 plus a whole power 3. You can understand this one. Cos 240 plus I sin 240. The value of cos 240 is cos 180 plus 60 minus cos 60 is minus 1 by 2, and this is sin 240 also sin 180 plus 60 minus sin 60 minus root 3 by 2. So it becomes minus 1 minus sin root 3 whole by 2. It is nothing but the value of omega square. So directly you can write this is omega square. Now you can calculate 1 plus a whole power 3n. 1 plus a whole power 3n. Right here 1 plus omega square whole power 3n. 1 plus omega square becomes minus 1. Right like this. Minus 1 whole cube whole power n. Of course minus 1 whole cube becomes minus 1. Omega cube is equal to 1. So right here this is minus 1 power n. This is minus 1 power n. Now theory bits 44th question. The value of minus 1 plus I root 3. The value of minus 1 plus I root 3 whole by 2 whole power 3n plus of minus 1 minus I root 3 whole by 2 whole power 3n. Students, you can understand, you should not forget the value of omega is, of course it is 2 by n. General notation of omega value is minus 1 plus I root 3 by 2, and general notation of omega square is minus 1 minus I root 3 by 2. So minus 1 plus I root 3 by 2 becomes omega. So it is omega power 3 power n right. Minus 1 minus root 3 by 2, just I said that this is omega square. Omega square power 3 power n right. Omega cube is equal to 1 we know, so you can write this is 1 power n and this is 1 power n. So 1 power anything 1, and 1 for anything, but the answer is 2. Okay students, we have successfully completed the theory bits. Let us going to discuss about the sums. Okay, level 1. We can discuss level 1 in next class. Okay.